Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us, we have Mia. And Mia, if somebody wanted to get a hold of us, what would they need to do?
For math homework, help call in Bakersfield 636-4357, toll free 1-866-636-6248, email dothemath@kern.org, or online at dothemathonline.net, and on social media, Facebook, Instagram, Twitter, and YouTube.
Nicely done. That's a lot of ways to get a hold of us, isn't there?
Yeah.
Now, before we get going, why don't you let everybody know where you go to school and what grade you're in?
I go to school at Greenway Academy, and I'm in 6th grade.
How is 6th grade?
Good.
That's pretty good?
Yeah.
Not too difficult? What's the best thing about 6th grade?
I like being on top of everybody in middle school.
Yeah, you like being at the top of the
Yeah.
food chain, huh? Do you know where you're going to be going to school next year?
Greenway.
So you'll still be at Grimway, but the part you're in right now, you're at the top?
Yeah. It just adds up.
Oh, all right. So that's not a bad deal then, huh?
Yeah.
So that's the best thing.
Yeah.
If there's something you could change about 6th grade, what would that be?
Longer recess.
How long is your recess now?
About a half an hour.
Half an hour?
Yeah.
How long you want for recess?
Like
Hour?
2 hours.
Oh my gosh. All right, well, you know what? It's not recess in here. You know why you're here?
What?
To do some work. So over to the board, young lady.
Here we go.
All right. Here's the first problem we're going to work on. So, Scott, I'll have you write the equation on the board, and then we'll have Mia work on it. 5, open parentheses, x plus 3, close parentheses, minus 2x is equal to negative 21. So, Mia, if you could, explain how you're going to solve this problem.
So first, I looked at the 5 and the parentheses, and I am going to times 5x and 5 times 3. And so I'm going to make a loop like that.
Oh, yeah? Okay.
Yeah.
You know what that's called? The distributor property. You're
Oh, yeah.
distributing the 5 to the part inside. Okay, go ahead and work it out then. Go ahead and multiply those together.
So
Good idea.
5x
Yeah,
plus 15.
good. All right. What's next?
And then
We're going to do anything with the 2x?
2x, and then we're going to bring it down.
Oh, gotcha. So it didn't go away. It's still there.
Yeah.
Good for you. Okay, what about the other side of the equal sign?
And negative 21.
So you've kind of rewritten this problem without parentheses. It's a really good start. I like what you did there. What are you going to do next? What's going on in your head? How are we going to solve this thing?
I'm going to do 5 and 5x plus 15 because in PEMDAS, the addition goes first. So
Gotcha. Addition definitely goes first. Now tell me this. Let's pretend that this X represents something like, I don't know, xylophones, right? Because xylophone starts with an X.
Yeah.
So here we go. We have 5 xylophones, and we're going to add to that 15, I don't know, dollars or something like that, right? It's different. It's not xylophones.
Yeah.
So we put them all in a box, right? 5 xylophones and $15. Mix them all up, and what do you got? You still have 5 xylophones and $15, right? They don't really go together.
Yeah.
So I like your idea of putting them together, but if you try to put those two things together, they're not really alike. Can you see two things that are alike in this problem that are over here on the left side of the equal sign?
5x and 2x.
There you go. Now, if you had 5 xylophones and you took away 2 xylophones, now we're talking, right? You're allowed to put those together. So I agree with your PEMDAS idea,
Yeah.
the idea that we need to do addition subtraction first, right? But let's go ahead and put things together that go together. So put those 2 things together. In fact, I'll go ahead and make a little arrow there for you. So what's 5x minus 2x?
3x.
Good for you. And the 15, is it still there?
And plus
Good.
15
Yeah.
equals negative 21.
Yeah, and you said 15, but I'm going to go ahead and keep that
Yeah.
1 there for
Oh,
you
yeah.
because it was 15. That's fine, no problem. So we're looking good. We have started off with a big long problem, and now we only have 1, 2, 3 terms left, so it's getting better, right?
Yeah.
What's next?
Since this doesn't have, isn't same, do we just leave it like that?
We just leave it like that, yeah, but we do need to eventually, the goal of this entire problem at the very end is to figure out what x equals, right? We want it all by itself. So is there a way we can move the 15 out of the way? Because we don't want it over there anymore. In fact, there's kind of like 2 sides to the equal sign, right? We have the left side and the right side. Can we make that 15 go to the right?
You could do 3, you can maybe do like subtracted 15.
There you go, let's do that. Because if you have a positive 15 and you subtract 15, that'll just go away, right? That's
Yeah.
wonderful. All we got over here left is 3x. However, you can't just do it to one side, right?
Yeah,
You
you
probably
have
know
to
that.
do
So can you subtract 15 on the other side as well, please? Good job.
4 and 1.
I gotcha. Now this is a difficult problem, huh? Negative 21 minus 15. And a lot of times students will kind of like, what are we going to do there? Here's a way to look at it. Let's say that this is the ocean, right? And you're going to go down 21 feet. That's what that says, minus 21. And then from there, you're going to go down even further, 15 more feet, right? So the question is, how far are you from the top of the water? It's not 14, because 14 feet would be like right around here somewhere. We're all the way down here. So what do you need to do to those 2 numbers to figure out how far you are from the top of the water? That's right. You actually have to add them. Even though it says subtract, you actually have to add them. So let me have you do this problem again, okay? And you're really going to add those problems, or add those 2 numbers together, and then we'll worry about the sign here in just a minute. So add them together. That's it. Now, are you under the water or are you above the water?
You're above.
All the way down here?
Oh no, you're under. the
Under,
water.
that's right. So what's the sign on the 36?
36 negative.
That's right, because we're below the water. All right, we have one last step to do. How are we going to get rid of that 3?
3x. Won't you? X is like a variable, so.
It is, that's right.
X, anything times a variable. So you do.
So you're saying 3 and x, this when they're squished together like
Yeah.
that means times, right?
Yeah.
So here it said plus, and you did the opposite, which was minus.
Yeah.
That was good. This is really a multiplication problem. What's the opposite of multiply?
Division.
That's right. So if you divide by 3, right?
And
Then that'll go away. And look, we have x, but you can't just do it to one side. So over there on your side, can you divide that by 3 as well?
36 divided by
Yeah, divided by 3. That's it.
3n, which is 12.
12, gotcha. So put 12 down here. And the last part, remember you had a negative 36 divided by 3. Is the answer positive or negative?
Negative.
That's it. Would you bet money on it? Would you bet money on it? Are you confident in your answer?
I'm confident.
How would you know for sure that that is the right answer? What could you do at the beginning of the problem to check it out?
You can do 36 and 3 times.
How about this one right here? What could you do with that problem if you went all the way back to the beginning? What would you do to see if it was right?
You do 5 times.
Put it here, right?
Yeah.
You put it here, and where
then,
else?
Right.
And you put it there. Wherever it says X, you stick that number in there, and you make sure both sides are equal, right? So that's one way to check it. I think you did some really good work there. Nice job.
Nicely done, Mia. Great first problem right there. 636-4357 is the phone number. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now, though, for today's Math in the News. All right, today's Math in the News has to deal with trash. We don't like trash, do we?
No.
Especially when it's in a place like this, right? You got the beautiful ocean, right? We've got
Yeah.
trash all around the place, right? So the biggest piece that you see right there, what is that? Do you know what that is?
Styrofoam.
The styrofoam, right? And what would that typically be used for?
Holding things in and keeping it circular.
Right, so you're holding something in that, and most often people put like leftovers and food and stuff like that in it, right? Okay. So I was watching the news yesterday, and there was something about styrofoam and how one person is trying to alleviate how much trash there is with takeout containers. Have you ever heard of these things? They're called munch bowls.
No.
Neither did I until yesterday, right? So there was a little story about these, and you can see these are the bowls, all right? And they're designed for takeout food, okay? And you can also, if you don't want to take it out, you can just eat with those bowls right there, okay? Now, I thought, all right, let's check this out a little bit. So there's the lady that was doing the interview. This is the person that made them, came up with, created them. And you can eat the bowl that the food is being presented in. Would you do that?
Probably not.
But you would be helping to save all that trash, right?
Yeah.
But we'd have to see what they tasted like first, right?
Yeah.
We don't want it to taste like styrofoam or cardboard, do we?
Right.
We want to have a little flavor to it. But I thought that was pretty cool.
Yeah.
But the reason more people are not doing that and why it's difficult to do is because the styrofoam container costs 3 cents. That container costs 33 cents. Okay.
Right.
So I figured, all right, here comes our math today.
Yeah.
All right. So have you worked with percents before in class?
Yes.
All right, so we can see the percent of change. So we take the amount of change, which would be 30 cents in this amount, right? So we're going to go from 3 to 33. That's a 30-cent increase over the original amount, which was 3 cents. So we divide the difference, right? And then we times it by 100. So that's a 1,000% increase. So would you ever like to have 1,000%? Like when you take a test, what do you usually get if you did really well?
100.
You get 100, right?
Yeah.
It'd be really awesome if you got 1,000, wouldn't it?
Yeah.
You'd be like, whoa, I must have done something really well, right?
Right.
So 1,000%, that's the reason why you are not going to see a lot of these things around
Regardless of how it tastes.
right now.
Comes back to
right? So
economics.
eventually, price on these things may come down. But I figured let's do a little bit more with percent. So, Mia, since you're here right now, so 0.334 as a percent. Have you ever worked with decimals going to percents?
Yeah.
Sometimes, right? So you can see that all we did is when you're working with a percent, you're working with 100. So all we needed to do here was move that decimal over 2 places. That's how you get the 33.4,
Wow.
right? Now here, 9.8, we're going to go backwards, put it as a decimal. So instead of going this way,
Okay.
we're going to go the opposite way. That's why it's 0.098. Okay? Then if you want to take 58% as a fraction, it would be 58 over 100. But you always want to simplify things if you can.
Yeah.
All right? So that's why we can see that it is 29 over 50. And that's just a little bit with percents. And who knows? You may be eating the container that you take home your stuff in one day. But that is today's Math in the News. 636-4357 is that phone number. Just a reminder, if you phone in to do the math today, December 4th, or next week, December 10th or 11th, and we do one of your math problems on TV, you automatically get yourself a pair of tickets to Holiday Lights at COM. Have you ever been out to Holiday Lights at COM?
No.
This is simply amazing. You will have to go to Holiday Lights at COM.
Really?
All right? And I know there are some kids out there going, you know what, I've been to Holiday Lights at COM. That's a pretty cool thing. You know what, let me call in and see if I can get some more tickets. That way Mom and Dad will be happy. I got tickets for free. I didn't have to have them pay for them. But if you'd like to know a little bit more about Holiday Lights at COM, that's where we're heading right now.
Today we are at COM and I am with Steve Sanders, Chief of Staff
That's right.
with Kern County Superintendent of Schools.
Correct.
How are you doing today?
I'm doing wonderful.
And today we're here to talk about Holiday of Lights.
We are. So this is our 17th annual Holiday Lights, and we are so excited to have another great year. Last year was a record year, and we hope to have another record year this year.
Now, when you're saying record year, what do you mean by record year?
So we had a record attendance. We had over 68,000 people last year. We made more money than ever, which all of the funds that are raised at Holiday Lights stay here at COM to support this amazing zoo. So it was a great year.
Now, you have a lot of things going on throughout the year, but this is your biggest fundraiser for CALM throughout the year,
That is correct. So it's put on by the CALM Foundation, obviously with CALM staff, and this is our biggest fundraiser. So last year we netted a little over $300,000 to be able to support all of the great things happening here. And so we put that money into new exhibits, into rehabbing our current exhibits, and just making the zoo better for our community.
And what is new here this year?
So in terms of Holiday Lights, what's new is we have a whole new layout for Holiday Lights. We have always had kind of a traditional layout with certain areas in the same place, and this year Josh Barnett and his crew asked if they could totally turn that on end, and so we're going to see a whole different layout than what people are used to. We have a lot of new displays, several out in the train yard that we may talk about later, and it's just, we have the same traditional favorites, but also new displays and a new layout for people to kind of see that it's changing every year.
Now, Josh, every year, he does, I know, change it up. He adds new things.
Correct.
Now, my favorite part is by the bridge and all that.
Oh, yeah.
Is that still there,
Well,
or they changed
the
that?
bridge is there. We're still going to have the pedestrian tunnel. You may see a couple of new tunnels, but that whole Winter Wonderland scene is now going to be a different scene, and Winter Wonderland will be in a different place. So I'm excited to see how it looks, and I know, knowing Josh and his crew, it'll be amazing.
Now, has he gone wider out, or is he still in the same parameter?
We're still in the same footprint, primarily because we still have some places to fill in, and we have certain animals that maybe don't like the lights as much, so we try to stay away from them. But basically, the footprint's the same, but as I said, a whole different layout and new displays.
Can you kind of tell us the time?
We'll go all the way through Saturday, January 4th, open every night but Christmas. We're open 5:30 to 9 every night. Gates close at 8:30. And Teen Challenge will be out here again. They're our partner agency. They do the party tent that we'll see over here, and then also concessions. So kind of a great way to support not only CALM, but Teen Challenge.
And there's lots of other sponsors throughout, correct?
There are. So during Holiday Lights, you'll see sponsor signs, and we have probably over 100 sponsors that contribute to help make sure that we can make Holiday Lights a success.
Now, if anybody wants to help out, who do they need to contact?
So you can just call the zoo, 872-2256, ask for Lana Fain, who's our zoo manager. It takes about 30 volunteers a night just inside the park. We have about 4 or 5 volunteers in the parking lot, so it's a big effort. And to know we go for, I believe it's 36 nights, that's almost 1,000 volunteers. So if people want to help out, it's a great way to give back and help the zoo.
Okay, so we are going to be coming back here in a little bit, CALM, but for now, we're going to head back to the studio.
All right, thanks for that, Mary Lou, and also thanks to Steve Sanders for helping us out with Holiday Lights at CALM. So now you got a little bit of an idea of what Holiday Lights at CALM is about, right?
Yeah.
Look like something you might want to go to?
Totally.
Totally, you know what? And how do you get Holiday Lights at CALM tickets? Do you remember what I said?
Oh, you call in.
You call in and you can get yourself some Holiday Lights at CALM tickets, right? Yeah. Well, you know what? Let's go to the phones right now. Caitlin, how are you today?
Good, how are you?
I'm wonderful myself. Nice to hear from you again. How is 7th grade going?
Good.
Good. You working on some difficult math right now?
Yes.
All right, well, it's a good thing you called in today then, right? What's the math problem that you're calling in with?
I'm trying to find the perimeter of a triangle.
All right. And I think we've got some of the sides already, and you know the perimeter, and you need to find an unknown side, is that correct?
Yes.
Okay, so go ahead and tell Scott what the numbers are.
X plus 3, 2x plus 4. And the perimeter is 6x, and we're trying to find the third side.
Gotcha, we're missing that side right there. Wow, interesting problem there. Is there anything else that you can tell us about this triangle here, Caitlin? Like, do you know the angles inside, or do you know any numbers at all? Or any, like maybe in the value of x?
No.
They don't even tell you what x is, huh? Okay, well, where do you want to start with this problem? What would you do first if you were going to solve this one?
I would combine the two sides.
Okay, so if we do x plus 3, combine that with 2x plus 4, Okay, if you add those together, then what happens?
You get 3x plus 7.
Yes, you do. You do get 3x plus 7. And that's very similar to what we were doing in that very first problem of the show when we were combining like terms. Put the x's together, put the numbers together. Okay, then what?
Then you're going to subtract that from the total perimeter, which is 6x, to find the unknown side.
Oh, right. Okay, so if you had another number here, we don't know what it is, that would equal 6x. So you're saying we put these two things together, and if we subtract that whole thing on the both sides, minus 3x minus 7, okay, what do you get?
3x minus 7 as the unknown side.
Yeah, 3x minus 7. Are you going to subtract it from the other side of the problem, or the other part of the other part of the actual triangle?
That would be part of the triangle.
Okay, so you're saying this is 3x minus 7 on that third side.
Yes.
Is that right? I like that. Now, how would you possibly know that that is actually the right number or the right actual expression for the third side?
You would add up all of the other sides and see if they equal 6x.
Let's do that real quick. Okay, so if you had x plus 3 and 2x plus 4 and 3x minus 7, and you add them all up, you're saying hopefully we get 6x, right?
Yes.
Let's see what happens. What's x plus 2x plus 3x?
6x.
Yep, that's it. 6x. We did those, and those. Here we go. 3 plus 4, what's that?
7.
Yeah, 3 plus 4 is 7. And then 7 minus 7?
0.
0. That's all we got left. If you were wondering at all, and if you can see on your screen, what I've done a little bit is the algebra version of it right here, right? Like as an equation like we had at the beginning of the show. And you can see we get the exact same thing. So the distributive property, what happened here, when you subtracted 3x minus 7 from both sides, right? It becomes negative 3x minus 7. That's what I did over here. 6x minus 3x is 3x. And the negative 7 comes down. And either way, the way that you did it or the way that I did it, we come up with the same answer. That's the third side. And the interesting part about this problem, to me anyway, is the fact that you don't actually have to know what the value of x is, right? X could be 2. X could be 5. X could be 427. We don't have to know what the actual value is to be able to solve the problem. I like that problem a lot. Thanks for calling.
Nicely done, Caitlin, and congratulations. You've got yourself a couple of tickets to Holiday Lights at Com. See how easy it is? Are you well rested now?
Yeah.
All right, good. So back to the board. All right. Mia, I would like you to select a number between 20 and 90, but does not end in a 0.
25.
25? All right, so 25 is up there. What I would like you to do is I would like you to write 25 hundredths as a decimal.
20, so 25.
Now tell me what's going on in your mind there, Mia. What are you thinking about?
So I'm thinking about place values.
Good. Place value is definitely a good place to start.
So
Okay, so if you have some place value here, let's say we have a couple of spaces.
yeah,
What's the first space on the left of the decimal? What's that one called?
the one.
That's the ones place, right? That's it. Now what about the first place to the right of the decimal?
Tenths.
Tenths, good. So we have tenths, T-E-N-T-H-S. And what's the next place?
Hundredths.
Hundredths, that's it. Hundredths, we're just going to abbreviate there. And the next place?
Thousands.
Thousands. You're really good at this. All right. This is the thousands place. So the question was, right, what Mike said, he said we want to do 25 hundredths, okay? And you seem to have a number that's in the thousandths place.
Yeah.
Not a terrible thing, but we really want to stick to the hundreds, just the tenths and the hundreds. So can you try this again and see if we can come up with something? Maybe that'll go away. There you go. So we definitely have a 0. Nothing wrong there.
25.
25. Which number's in the tenths place?
2.
The 2. And which number's in the hundreds place?
5.
That's it. And so we actually have 25, right, that whole number, but the last place is in the hundreds place. I think that's a good way to do it. Nice job.
All right, so now we have 25 hundredths written in decimal form. Now what I'd like you to do is put that as a percent. So I see 25%.
So it would be giving this going that way.
Yep.
And then it would be dot, and so it would be 25%, like that.
Yep, and you can put the percent on the other side if you want to, but that's it, 25%. And one of the ways, if you ever get confused, is think about this number here that you had earlier, right? If that was on a cash register, how much money would that be?
25 cents.
25 cents, right? So when you go change the percent, you just have to take that number, 25, and write a percent sign after it. Nice job.
All right, now let's turn it into a fraction and simplify it if possible.
Ooh, that'd be fun.
So 25, since we brought it this way, we're going to bring it that way.
Well, we would do that, but we're looking as a fraction, right? So here we have a fraction,
Yeah,
okay? And what's the number that goes on the top? The number that we have here?
25.
25. Okay? What's the number that goes on the bottom?
1?
It could be 1. If it was a whole number, if it was a whole number like 25, it would definitely be 1.
Yeah.
But we're really talking about, remember, we're talking about 25 cents. So we have 25 cents. How many cents are in a dollar?
10 for like, what type?
How many pennies are in a whole dollar?
100.
100. So that's the number we want there, because really what we have is 25 out of 100 pennies. Okay? So can you take this fraction, maybe make it a little bit more simple? How are you going to simplify that or reduce it?
So what can 25 and 100 go into?
Yeah,
That's
what goes into them?
It can go into, that can go into both one time, but it would be the same number. 3?
You think 3? Does 3 go into 25? No, not quite. Keep thinking though. I like the way that you're thinking kind of out loud here. 3 doesn't work. See, 2 doesn't work. We know that. 4. Does 4 go into 25?
No.
No. What about, what's the next number?
5.
5. Does 5 go into 25?
Yeah.
All right. Let's divide them both by 5. Divided by 5 and divided by 5. Go for it. What's 25 divided by 5?
5.
Good. And what's 100 divided by 5?
1?
Not quite. Nope. Bigger than that. You want to work it out over there?
Sure.
There you go. 100 in the middle and 5 on the outside. Good.
5. So 5 can go into 10
2 times. Good. That's okay. It's kind of a little scratch work over there.
And then it goes into it 10 times.
Good for you.
Minus that.
And then you still got to bring that 0 down. That's the part people forget sometimes.
5 can go into 0 times.
There you go. Good for you.
And then
And then there's just a bunch of zeros left over,
0.
right? Okay,
Yeah.
so what goes in the bottom here? 100 divided by 5?
20.
20. There you go. Are we done? The answer is no. Say no.
No.
No, we're not done. Of course not. We have more to do.
Yeah.
So can we make this fraction even more simple? How are you going to make 5 over 20 even more simple? What number goes into 5 and 20?
5 can go into no, not 3.
No, not 3. Not 4.
5.
5 goes into 5, definitely. Does 5 go into 20?
Yeah.
Let's divide by 5 again. What a good idea. Divided by 5, divided by 5. Take it away.
So 5 divided by 5 is 1.
Good.
And 20 divided by 5 is 4.
That's it. So that's the reduced version or the simplified version of 25 over 100. Can you think real quick, since we were going to go to 1/4 anyway, we ended up there.
Yeah.
How could we have skipped this one right here? What number goes into 25 and 100 both? What bigger number? Because we did 5, that worked, but we had to go again. So if you didn't want to go twice, what bigger number could you do?
Could you do 10?
Well, how would you make a 1? What would you divide by? 25 divided by something equals 1. 25 divided by,
10? No, not 10.
not 10.
50.
25 divided by something equals 1.
25 divided by,
Itself, right?
yeah,
Yeah. So what is itself?
25.
25, that's it. Sometimes those easy ones really throw us off because it's like,
Yeah.
that couldn't be the answer because it's too simple. But this is how you could skip that middle step, is if you divided by 25 on both of them. 25 divided by 25 is 1. 100 divided by 25 is 4. So you could skip that step. Nothing wrong with what we did,
Yeah.
but if you wanted to go a little faster, you could find a bigger number. I like how you did that. Good work.
There you go. Well done. Decimals, fractions, and percents. Well, you've done some great work right there, and you've got yourself a meal courtesy of our friends at Grillin' Burger. So congratulations on that. Hey, just a reminder, we do have phone tutors available until 5:30 if you'd like a couple of Tickets to go see Holiday Lights at Com, all you have to do is give us a call and they're all yours. We'll be back with more right after this.
Today we're at Norris Elementary School, home of the Squires, and we're here to We're back at Norris Elementary School working with some 6th grade students and going to do some work with pentominoes again today after they learn the basics about the squares and congruency. All right? Have you ever worked with pentominoes? Anybody know what pentominoes are? All right. Well, you know what? Let's take a look at these. Have you ever worked with these? Some of you have, some of you haven't. All right. So here's what we're going to do. Each of you is going to get your own set of pentominoes. All right, so there's yours. And what I'll do is just pass them down and just make sure that the person next to you doesn't have the same color. That way they don't get mixed up. Let's see, we can put another blue down there, right? You want a red, and let's see. Oh, that's it, we have a purple one in there. All right, so go ahead, take them out, spread them out. You can just put the bags on the floor if you want next to you so that they're out of the way. Now, take a look at the different pentominoes. What do you notice about them?
They all have 5 squares.
They all have 5 squares. That's the key. All right, they all have 5 squares. All right. Now, some of your shapes may not have the little lines on it, but they do all count as 5 squares. All right. Here's what I'd like you to do. Just take a couple of them and put them together somehow, then see if you can make a little something. Just anything at all that you would like. You don't have to use all of them. You can use 2, 3, 4, whatever you like. Just put a couple of them together and see what you come up with. Kind of like puzzle pieces, huh? Seeing if you can fit them together and make something. So you guys see how they kind of fit together? Yeah. All right. And some you might have to turn or flip over in order to make it fit a little bit better. All right. Here's what I want you to do. On your plain white piece of paper, I want you to make a rectangle. But the rectangle has to be 3 by 5. Okay? So, if I take this piece and I put it right here, I know I've got 1, 2, 3. Okay? And I've got 1, 2, 3. So how many more can I go down? 2. 2. And then I've got to fill all this in also. Right? So what I want you to do is I want you to see if you can make a rectangle using any combination of pieces that will make a 3 by 5. And you just do it right on top of your white paper. And then if you get it, we'll trace it out and see what shapes you used. All right, so go ahead and try that. You've got a 3 by 5. So what 3 shapes did you use?
I used this piece,
Okay.
this piece, and this piece.
Okay. Now these pieces actually represent letters so that people can tell them apart sometimes. So look at the 3 pieces that you used again. All right.
C, P, and Z, I believe.
That one's going to be classified as a Y. So if you kind of put it sideways a little bit, like tilt it, you see how it's a Y? Okay. So you have a C, right? And then the P, what else could it be besides a P if somebody wanted to make that a different letter?
D.
It could be a D or a B, right? So there's 3 different ways you could do that. And then that other one that's a little bit off, that's the Y. So by using those 3 shapes, you're able to make a 3x5 rectangle. And there's another way to do it, and we'll let the kids work on that as they continue at Norris Elementary School.
And once again, a big thanks to the students out at Norris Elementary School. We had a great visit out there with those students. Hey, we do have phone tutors available until 5:30. We have Mia, a 6th grade student from Grimway, in studio with us doing a little bit of work. But right now we're going to head out once again to COM and check out a little bit more about holiday lights.
We are back at COM, and I'm with Steve Sanders, Chief of Staff at Kern, Superintendent of Schools. And again, the Holiday of Lights is just kicking off.
It is.
And we were kind of talking, we've been here over the years, and Josh has been talking about the lights and how he's been switching over to the LED.
Correct.
Do you know if that switch is complete, or are there still some of the original
So
lights?
we're about 98% LED. Every year we try to replace some of those older displays from the first year, and so we have a few left, but we're almost all LEDs, which is great for a couple reasons. One, they pop in terms of really looking brighter and kind of attracting people's attention, but they're much more energy efficient. So we're able to use less electricity, fewer generators, and it just kind of helps overall in that way.
Let's talk about the generators.
Sure.
So when you started 17 years ago,
Yes.
obviously your power was a lot different.
Yes.
What did that look like?
Well, not only we didn't have LED lights, so we were using more power, and I think they had 7 or 8 generators spread throughout the grounds. We're down to 2 generators, only out in the train yard. We've added some electrical throughout the zoo to help us, and so my hope is by next year we'll get rid of those generators and be able to go entirely on power. And then someday I'd love to have solar out here, maybe over the parking lot, where we can also benefit from that technology as well.
So you were saying about a lot of changed, right? Approximately how many lights? Because he's adding lights every year, correct?
He is. So we haven't physically counted them recently, but we're over at well over 3 million lights. He started with 2 million back 17 years ago, and we've added a lot more displays. So when we sit down and kind of calculate it out, we're well over 3 billion lights. And again, we're kind of in the same footprint, but we've added a lot new displays. You can tell they've wrapped the trees. So they take a lot of time to make sure that it looks great.
Let's talk about the time.
You bet.
When does Josh and his crew kick off?
So they are out here starting mid-September, and they're starting to put up the lights, and then I'd say really the last month or so, he has a full crew of anywhere from 10 to 20 people working full-time to make sure that the lights are wrapped and ready to go. So there's obviously a lot that goes into laying the power, wrapping the lights, making sure the new displays are up and working.
And as we've been walking around here at the park, we've been seeing people still working.
Yes.
Now, will there be a crew continuously checking lights
There
throughout
will.
the 36 days? It's 36 days, correct?
Exactly. So yes, Josh is here, and then he has several crew members that are here every night to make sure we get started and there's no issues, and that they can address anything that comes up. But we haven't, over the years, we've kind of perfected it, so we don't expect many problems at all.
Now, when he takes everything down on the 4th, January 4th,
Yeah.
it's obviously a lot quicker to take down
It is.
than
It
to put
takes them
up.
about 3 weeks to take down. So they'll unwrap all the trees, they'll store the lights, they'll take down the big displays. So, You know, it takes what, 3 or 4 months to put them up and about 3 weeks to take them down.
Does he plan all through the year for this, or?
He does. So he and I usually meet in June or July to kind of plan the new displays, and then he goes back and is building them. And then Josh does other shows throughout the country. So he has a couple shows in Texas, in Utah. So not only is he working on holiday lights here at Calm, but he's working on other zoos as well.
And as the sun is going down
Yes.
behind us, you
Yeah.
can see everything is coming to life. And it's
Exactly.
really quite a magical time to be here.
It is. We're in what's called the tree show. So this area is sponsored by Chevron typically, and it's a kind of a musical tree show that's one of the hallmarks of holiday lights. And you know, it's a chance for us to showcase one of our biggest sponsors, which is Chevron. And we have probably 100 other sponsors that all contribute to help make holiday lights a success.
Okay, well, there's going to be more from here at Calm with Holiday of Lights, but for now, we'll send it back to the studio.
All right, thanks for that, Mary Lou. Well, in studio, we have Mia with us, a 6th grade student from Grown Way Academy. Ready to do some more work?
Yeah.
All right, over to the board. So we're going to do the same thing, fractions, decimals, percents. We're going to do all of that. I will give you the number, though.
Okay.
All right? So I would like you to write 2 8/8.
Tell me a little bit about how much money this is.
So it would be in cents, so 28 cents.
Right. And that's not really in the thousands place, right? So we want to see if we can change this up a little bit. I definitely like the 2 and the 8, right? So he said, and it sounds like we're going to have a whole number here because he said that word and that usually means a decimal place. But we want to make sure there's something way over there in the thousands place. Try again, right? Listen to the number closely. 2 and 8 thousandths. All right, here we go. Definitely thinking hard. I like it. So we definitely have the 8 in the thousandths place, okay? But once again, we want to think about that word and. The and means decimal, okay? So we want that 2 to come before the decimal. See what I'm saying there? So let's go ahead and put that 2 as a whole number. And the reason we know it's a whole number is because it's 2 and 8 thousandths, right? So where does that 2 go? I'll give you a little bit of room there. Good, so there's the 2 and 8 thousandths. What about that one spot where the 2 was? There you go. Nice job, 2008, look at that. But it's 2 and you backfill with these zeros here because we don't have anything else to put there. All right, what are we gonna do with that next?
Let's turn that into a fraction.
Ooh,
That's why I wanted to have the and in there.
yeah, no doubt.
So we have a whole number and a fractional part.
My goodness. Any clue about where to go? Let's talk about that for just a second to make sure we go in the right direction here, man.
You go back.
Well, we want to make it into a fraction, right? So I'll just write a big old fraction bar. What number goes on the top?
2.
Definitely a 2, right? But we have to have everything. Everything that you see there can't just vanish, right? Has to be everything.
20.
So ready, we're going to write the whole thing. 2, 0, 0, 8. The whole thing has to be there. Zeros here, right, in the middle, they count. If you had a bunch of zeros on the end over there, they wouldn't count anymore. But those zeros definitely count. So 2008. Now here's the big question. What number do we have to put on the bottom?
1,000,
It is 1,000. Do you know why?
because it's 2 and
Yeah, and you have, and
1,000.
here's the way I like to explain to my students. I put a 1 for the decimal, and then 1 0 for every spot afterwards. Nice job. 1,000 on the bottom there. Do we need to do anything else with that? What do you think?
We have to simplify it.
We could simplify it, yeah? Is that part of our problem too?
Of course it is. You know you have to simplify
Let's do
everything.
it. 2008 over 1,000. What do you want to divide them by? Any ideas?
Can we divide it by 2,000? No, not 2.
It could be a really big number. What's a simple number you could do that you know for sure goes into them? Because there could be a bigger number. Even I can't think of maybe the biggest possible number that'll go in there. But what's a smaller number that you know for sure is going to go into both of those? Are they both even?
Yeah,
Okay. So what number definitely goes into both of them?
2.
2. Okay. So if you divide it by 2, we'll make a new fraction. What's 1,000 divided by 2? Half of 1,000.
500.
500. Good for you. Good. And then if you want to work out over here, 2008 divided by 2, give that a try. Good. That part goes in the middle, and then we got a 2 on the outside, right? Okay, so we're divided by 2. What do you get?
So 2 goes into 20 10 times
Oh, I like how you did that there. That's cool.
20. And then you minus it, which is 0.
Mm-hmm.
And then you bring down the 0.
Remember this? Yeah, that's right. Bring down the 0, and you got to put a 0 up there, right? Yeah, don't forget that part. I'm glad you brought down that 0. And then what else can you bring down?
And then it goes into a 0 times, so I'll bring down the 8.
Good. And give you a
And
little bit
then-
more room there. Oops. Okay.
2 goes into 8 4 times.
Mm-hmm.
So 8 goes into 8 times.
That's it. 1,004. Do you think we're done?
No.
No, probably not. How come? What can you divide these by?
You can divide 5. We can divide it both.
Are they both even again?
No.
Yeah, these ones were even, right? We had a 0 and an 8. We got a 0 and a 4. They're both even. Let's try 2 again. Why not? Because we're getting good at that. Can you think in your head what's half of 500? We can work it out if you want to.
Yeah.
How about you over here? You can do 1,004 divided by 2. And over here, I'll do 500 divided by 2. And we'll see who gets it first.
Okay.
Ready?
Yeah.
Here we go.
So
5,
2 goes
2,
into 10.
4, 1. I'm not throwing you off, am I? 2 into 10, 5.
Minus 0.
Mm-hmm. A little more room?
Yeah.
Okay. Oops. Get down there. We want to extend the page there. Oh, now we got
That's a lot of room.
So 4. And then 2 goes into 4 2 times 4 equals 0.
Right about the right time. Good. So I got 250, and you got
500.
502. Are we done?
No.
They're both even again.
Yeah.
So who knew at the very beginning? I guess we could have divided by 8, but we didn't know that at the time. Let's try at least one more. Can you think of what half of 250 is?
250.
If not, then you can work out this
Yeah.
problem. 502 divided by 2. Ready, go.
So 5 can go into 250. 5 2.
Move it up a little
5 can't
bit.
go into 5 can't go into 2.
2 goes into 5, right? 2
Yeah.
times.
And then
And then you can multiply it and go down there.
4 subtract 1 12
Good.
6
Oh, we want to bring down, this is a 0, remember that?
yeah.
So we want to bring down the 0 here.
0
So this is going to be a 5.
5.
Okay?
And then so 2 goes into
So 5 times 2 is 10. You were doing a really wonderful job here. Now you're going to bring down what?
the 2.
That's it. How many times did 2 go into 2?
1
251.
2 minus 1.
That's pretty good. I think that's about all we're going to get, because the only number that's going to go into 125 is something that ends in a 5, and 251 can't be divided by 5. So, man, I hope we're done. Although, if we really had to, we could probably change this into a mixed number, right?
That'll be the end of that right there. We'll stop on that. All right, erase the board. Mia, you've done some excellent work today. You deserve a bonus question.
Oh, nice.
No more fractions, decimals, or percents. I like the giggle out of you right there. Scott, I've made you do this many times.
Yep.
Today is Mia's turn. 4 4s on the board.
4, 4.
Mia, select a number between 1 and 9.
5.
You have to use all 4 4s. You can add, subtract, multiply, divide. Use parentheses, any mathematical symbols you like. You have to use all 4 4s, no other numbers. And you have to make them equal to 5. And I will give you not 4 minutes, but 3.5 minutes.
All right. Okay, what are your ideas here?
First, I'm going to subtract
Okay,
that,
good,
which would be 0.
good. And you got 2 4s left.
4 and 4. And then subtract. I would subtract that, but that would just be 0 and 0
Yeah,
is 0 is
that'd
0.
be 0, that's right.
Can I add numbers?
Sure. No,
You
you
do
can't add any
anything you
numbers,
like.
but you can use an addition problem. You can use an addition sign. Definitely takes some planning, doesn't it?
Yeah. Wait,
Yeah.
Can I get rid of that?
Can't get rid of them unless you do subtraction, I
Yeah.
guess. Yeah, but then you just have 0, but you got to get 5.
Can I erase this?
Yep. Yep. Want to try again?
So like that.
Okay, let's see what you got there.
And then I'm gonna restart my thing.
You're gonna start again. Okay.
Yeah.
So we're not gonna subtract, but we're gonna put some numbers together. You picked the tough one. Got a 5. So we have all even numbers, and somehow we have to get an odd number, right? So you got to think about how are we gonna make it into an odd number? That's kind of a weird deal, because if you just add them and subtract them, then you're just gonna have even numbers keep going,
Yeah.
right?
So I think I'm gonna times
Okay.
these two, which equal 20.
Oh, try again. What's 4 times 4?
Oh, 16.
16. Okay, good. So 4 times 4 is 16, and then how are you gonna get back down to 5?
And then I'm gonna bring these down.
Yeah.
And 16 minus 4. Should I do minus 4? Yeah. I'm gonna do minus 4.
Okay. 16 minus 4 is 12, and you got one more 4. Can you make it into 5? Boy, this really makes your brain work, doesn't it?
Yeah.
Yeah. It's a great problem. By the way, just so you know, it is possible.
It is?
Yeah, it is possible.
Oh, there's many
He
ways
wouldn't-
to do
he wouldn't
each
give
one
one of
of
those
these.
ones
So
be
there's a lot
frustrated,
of
not
different
possible.
ways. You are on the right track.
Definitely.
Okay, so keep going and tell us what you're thinking about. You've got plenty of time.
That wouldn't equal that because that would just. That
So
wouldn't equal
12
five.
minus 4, what would that be?
That would be 12, 11, 10, 9, 8.
It'd be 8. That wouldn't work. What about 12 plus 4?
That'd be.
That'd be too big.
Yeah.
12 times 4. That's
that'd
too
be
big.
yeah.
What about 12 divided by 4?
I could try.
Yeah? What is it? Just out loud. What is it? What's 12 divided by 4?
That would be 12 divided by 4 is 3.
3. That's right. So we're a little bit low on that one. But at least we got to an odd number. That's
Yeah.
good. So you might want to use
So
some
here's
division
your
here somewhere
clue.
too. All right, here's a clue.
You, like I said, you started off right, so you're going to leave the multiplication first.
Okay.
Yeah.
You're going to start with multiplying.
Okay.
So keep the 16, and then you need the key is the next step.
So could I do 16?
Because last time you subtracted 4, right?
Yeah.
Okay, so instead of subtracting 4, what should you try?
Adding
Try it. Let's see what happens.
16, 17, 18, 19, 20.
Good for you. 20. And then you still have a 4 left. How are you going to make that into 5? What the heck?
I'm gonna do division.
Ah, okay.
And
Put your
then
division sign right there.
so ah.
That's all right. Go ahead. You can put it there.
And that would equal 5.
20 divided by 4 is 5. So if we had to go back and put the signs in here, right? Times first. And then what comes next?
Adding
Adding. And then what comes last?
division.
Division. Now, you were telling me at the beginning of the show something about PEMDAS. What's PEMDAS?
It's like an order of operation.
It is order of operations. So if you looked at this problem and did the order of operations with this problem, which part would you do first?
And that we're going to let Mia concentrate on for just one moment. All right, so you can think about that, Mia, because right now we're going to go out for our last opportunity to visit with Mary Lou and the folks at Calm and Holiday Lights.
We are back at Calm, and I'm with Steve Sanders. And now we're at a different part of Calm.
Oh yeah, one of my favorite places at Calm.
I love this. I
Yeah.
love it. It's the trains, which is so exciting.
Yeah, so this is our train shop where all the magic happens. Behind us is the Circle of Knowledge where all the train guys get together and solve the world's problems. But it also, this is where everything happens related to the trains. And one of the things that people don't realize about our trains out here at Calm is it's all volunteer run. So we have a crew of probably 20 amazing men and women who come out here on weekends and every night of Holiday Lights and not only built this railroad and everything that goes with it, but they operate it on a weekly basis. So it's an amazing thing.
How long have the trains been here?
The trains have been here, I want to say, since about, boy, you're going to test my knowledge, 2002 or so. So it's been a while. And they have operated pretty much on the weekends and again every night at Holiday Lights during our special events. And it's really become a favorite of CALM.
I know when I come out, I have to ride the trains because it's just so special going around.
Yes.
Now, these, I know they're actual replicas, is that correct?
Yeah, well, these are true trains. So this is our Huntington train, and this is what we call the American. Both trains will operate during Holiday Lights, and we'll pull our passengers through. It's about 2/3 of a mile around. Takes about 7 minutes to go around the track. But it's a great way to see not only the displays that are out here, but during the daytime to see parts of CALM that maybe you don't see when you're walking around.
And also, the trains don't only operate during this time of year.
Correct.
They are on another time, the weekends, correct?
Yeah, so we typically operate on weekends and then during Spring Fling and Boo at the Zoo and our other events that we have out here at CALM. And it's definitely a favorite. I always tell people when I see a young child walking out of Holiday Lights and they're crying, the only reason is because they haven't ridden the train.
I would be crying too.
Yeah, me too.
Now, I know when they're going around, the dinosaurs were like one of the first
Oh,
there.
yeah.
Are they still out there?
So the dinosaurs are still out there. You may even see a new a Santa hat or two on them this year for Holiday Lights. But we had one dinosaur originally, and then we picked up the other dinosaurs from Buck Owens and his family. When he passed away, he had them on his ranch north of town, and they offered them to CALM, and they're definitely a favorite of the kids.
Is there anything new out here in this area?
There is. So we have, when the train goes around the station and starts its journey, you're going to see a whole new display. We normally had the Toy Factory, which was kind of one of the big displays that you saw during Holiday Lights. That's been replaced with a whole new scene. And so we have definitely a few different displays out here that are new.
Now, can people still come out and help out with the trains? Because you said it's all voluntary, correct?
It is all volunteers. So yeah, we get volunteers on weekends and throughout the year. Not only volunteers that know how to build all this stuff and take care of it, but also volunteers that help run the train. So we're always open for volunteers at the train and also throughout CALM. You know, that's one of the things that makes this place work is our volunteers and docents.
Okay, so to wrap it up,
Yep.
again, you're here until January 4th.
We are here every night till January 4th, except Christmas, and we're open 5:30 to 9 o'clock every night. Tickets are available here at CALM at the door, and then Kern Schools Federal Credit Union, which is a partner of Do the Math, they are also selling tickets for us in advance of Holiday Lights, so you can get those at any branch.
And Teen Challenge is out here too
Teen
with
Challenge is out
with
here doing the
booths?
food, the party tent, helping with parking. So it's a great way to support not only CALM, but a great agency and Teen Challenge.
Thank you so much for
Thank
your
you,
time
Mary Lou.
today.
Appreciate
All
it.
right, so come on out here, 5:30 to 9.
Yes, ma'am.
Till January 4th, closed on Christmas. And that's it from CALM today. Back to you at the studio.
All right, thanks for that, Mary Lou and Steve. And you know a little bit more about Holiday Lights if you call next week, December 10th and 11th. To do the math, you automatically get yourself a couple of tickets to Holiday Lights. Mia, what did you decide to do at the end of that problem?
I decided to put parentheses around 4 times 4 because that's the first thing I did when I solved this problem. And the second thing I did was add 16 plus 4. But in PennDOS, you usually do division first. So I made sure that you do this one next by putting another set of parentheses. And then I put division at the end.
All right,
Nice
nicely
job.
done. Well done on that. We certainly hope. Did you have a good time today?
Yes.
All right, good. Well, congratulations on that. We certainly do appreciate you coming in. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.